Okay guys, so we are going to take care of on this video the 7.2 notes, which is going to focus on us finding maximums and minimums of polynomials. So I want you to start out by generating a graph by hand without a calculator of this function. So go ahead, pause the video, get a graph of that, and I'll show you once you restart the video what that graph should look like. Okay, so go ahead, pause the video, draw the graph of this. It's a quadratic, we should know what that looks like. Okay, once you're done, you should have something that looks like this. My parent function, I'll just sort of real quick show you how I got where I did, is the blue one here, and we have the points 0, 0, 1, 1, negative 1, 1, and 2, 4, negative 2, 4. And then what's happening is this minus 3 on the inside moves everything to the right, 3 units, so every point moved over 3. And then from there we took care of the 2 in front, which is vertical stretch, which is my green graph. That means I multiplied all the y values by 2, so these now are at 2, these are now at 8. This one stayed because 2 times a y value of 0 is still 0. But then from there, we address the vertical translation, so I move everything up 5. So this is my final graph over here, and I want to point out that that is a minimum. Okay, and that's important because later down the video, or later down your note sheet, I ask, what does it have, a max or a min? And we know that this graph, not only do we know it's a minimum from our picture, but we also know it's a minimum because the a value, the number in front, it was a 2. That means it's greater than 0. That means we're going to open up. So we studied, those quadratics quite a bit. We know that the vertex is always a minimum or a maximum. And we also know from our recent discussions that quadratics are polynomials. Okay, and that quadratic had a minimum. Other polynomials might have a minimum and a maximum, or maybe they just have a maximum, or maybe a plethora of both. So what we want to focus on finding today are those maxes and mins, and they always occur at a turning point. Every turning point is a maximum or a minimum. Now, a turning point is when your graph changes direction. Okay, so every time our graph changes direction, we're going to have a max or a min. And I have a picture of, each situation here. This point right here, we call that a local max because it sort of looks like this graph might be coming back up this way. And that's a local max because it certainly is a mountain peak. It is higher than the points around it, but it kind of looks like the graph might be going up higher than that point eventually. It's sort of like saying, in Pittsburgh, Mount Washington might be the highest point, but it's certainly not the highest point in the whole world. Locally, it might be a maximum. Okay, but I think it's important for right now that you realize that every mountain peak on our graph is going to be a max. And then every valley is going to be a minimum. Now, it might be a local min if the graph eventually goes lower than that particular point. It might not be the lowest point. In that case, we call it a local min. But it's certainly lower than the points around it. It's forming a valley. Sometimes these maximums and minimums, the book will call them the extrema. You see that word extreme in there. Extrema of the function. So if they ask you to find the extrema, that's what they're referring to. Find the maxes and mins. And this is what we're going to focus on the back of this page. So turn the page over. Our goal is going to be to identify maximums and minimums, and use to determine where the function is increasing or decreasing. Nope, I'm running out of room. Okay. Now the good news is on these kind of problems, I'm going to ask you to do a lot of graphing, and you're not going to be able to graph by hand, so you're going to need to use your calculator. So if you have your calculator, pause the video, take it out. If not, go borrow one of mine. But you're definitely going to want to follow along with this process. So first thing we're asked to do is graph this function. So to graph it, we're going to enter the equation into y equals. So hit y equals. I have the equation in there already, but again, go ahead, type it in, x raised to, get the little caret to the third, plus 3x squared, minus x minus 3. And when you hit graph, if it gives you an error message, go back, hit y equals, and make sure that your plots are unhighlighted. That could be a reason why. If it still gives you an error message, hit zoom 6. That's probably the other reason why. But everybody should eventually get to a screen that looks like this. And you're going to want to just draw a quick picture. So anytime on the homework that you're using a graph, you're going to want to draw a picture. It doesn't have to be a masterpiece, just a general idea. And you can see on the picture that we have a mountain peak and a valley, which means we have a maximum and a minimum. These are local maxes and mins because the graph keeps going up and down, so it definitely gets higher and lower than these points, but locally we have maxes and mins here. So to find the maximum, let's say we want to find this point right here. We've done this before. You actually hit second trace and you choose maximum. And when it says left bound, you move your cursor to the left and hit enter. And then you move your cursor to the right and hit enter. And then you move your cursor closer to the actual maximum and hit enter. And that means we've got a maximum at negative 2.15, comma 3.08. So that's what we'll record under maximum. For the minimum, similar idea. We're going to hit second trace. We're going to choose minimum this time, whole left bound, right bound thing, now just for that valley. And you may remember that, I said this earlier this year, you know you're done when you actually see the word either minimum or maximum. So we have a minimum at 0.15, comma, negative 3.08. So really that whole part is not new, finding those mins and maxes. You've done that before earlier this year. What will be new is talking about the interval of the domain where the graph is increasing. So first of all, let's dissect this a little bit. We know the domain refers to x values, okay? So we're going to look on the graph where there's where we're going up. That's what increasing means. And where on the graph are we going down? So go back to our graph. When you read a graph, when we're talking about the interval of the domain, we want to work left to right. So I like to say, pretend this is a roller coaster and you board the roller coaster over here. The first thing you would be doing is going up. So this part is your increasing part. It's not the only part that's increasing. You would also increase from this valley up. So these parts are your increasing parts. Well, the part that I just sort of highlighted in green, we know that those are the increasing parts. Just write the domain for those parts. So domain would mean, what's our leftmost x value? Well, technically the graph keeps moving to the left. So our leftmost x value is negative infinity. And then we would keep increasing to negative 2.15. Now, We don't include the negative 2.15 because that tippy top point is sort of neutral. You're no longer increasing and you're no longer decreasing, so we don't include it. Notice I didn't look at the y value at all, and the reason is because we're looking at the domain, which is x values. All right, over here, we just want to write the domain of this part. We're going to link these two domains together with a union symbol, okay? And we start at an x value of 0.15, and because this graph keeps moving over and over and over forever, would go to an x value of infinity. Now, interval of the domain where we're decreasing, that's where we're going down, and that would be this part. So, what's the domain of the red part? Well, that would be from, again, domain is x value from negative 2.15 to 0.15. And there you go. Okay, so what I want you to do next, I want you to pause the video. Pause the video and do the next example yourself. And then start the video and see how you did. See if you were able to get the right answers. And I'm going to go through it in the meantime, and when you start the video, you'll watch me go through it. So for the next one, we have a new equation. We've got to get that into y equals. We have to graph it. All right, we get a picture of it. It's not the most beautiful picture, but it'll do. We have to find our maximum. So second trace, choose maximum. Got to do the whole left-right thing. We have a maximum at 1.155, comma 6.63. We got a minimum at negative 2.22, comma 3.89. All right, so maximum at 1.55, comma 6.63, minimum at negative 0.22, comma 3.89. Okay, interval where we're increasing, there's actually only one part where we're increasing here to here, the green part, and that would be from an x value of negative 0.22 to an x value of 1.55. Decreasing would be there and there. Okay, and that's going to be from negative infinity, because I know this looks like it's going up, but as it's going up, it's also moving to the left, which means your x values are getting closer and closer to negative infinity, and it keeps decreasing to an x value of negative 0.22, but we have another decreasing part, so we need a union, and we would go from 1.55 to infinity. Again, I know that looks like it's going down, but we're talking about the domain of that part, and as it's going down, the x values are getting bigger and bigger. So that's example 2. Hopefully that example went pretty well for you. Again, I want you to pause the video, try the third example yourself. Once you restart the video, you'll be able to see how you did. Okay, so enter our equation. So once we have it graphed, you can actually see that this one has 2 maximums, and that can happen. And we have a maximum First one right there is going to be negative 1 comma 5. That's nice that the numbers are a little nicer there. Second maximum. Second maximum would be at 1.59 comma 6.62. Okay, we have one minimum. And that looks like it's at 0.16 comma 2.92. Okay. Okay, so this one has a couple increasing and decreasing intervals. So increasing here and here, so we got to write the domain of those parts. So negative infinity to negative 1 union 0.16 comma 1.59. Again, I'm not using any y values over here because that would be not the domain. Domain is only x values. Decreasing would be this part and this part. And if we're decreasing, first we're starting in at x value negative 1, going to an x value 0.16, and then again from 1.59 to infinity. Whew. Okay, so what you're then going to do, and this will be checked tomorrow, is you're going to do these problems. I have a screenshot here of the homework problems. The page number's posted on Blackboard, but I wanted to talk about something that you're going to see. You've got all these equations, and then there's this semicolon here. I basically want you to ignore everything after the whole semicolon. Just do these problems just like we did in class. Okay, make sure you draw a graph for each of them, otherwise it won't give you full credit. You do need the graphing calculator in order to complete them, so make sure if you don't have one at home, try to get this done before you leave. Okay, I'll be back tomorrow and we'll pick it up from where we left off.